Hare Krishna everyone. Today I am going to start a new lecture series on quantum mechanics. So welcome to my first class of your quantum mechanics. So let's get started with a photoelectric effect. This is our first class of your photoelectric effect. Okay. So let's get started. Let me write the headings. Photoelectric effect. Photoelectric effect. Okay. So 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 in photoelectric effect, what does it signifies? It signifies your corpuscular particle, or in simplified language, you can say it shows the particle nature of light. It shows the particle nature of light. Particle nature. Okay. So in photoelectric effect, we study about the photons. That is your quantum of light, that is your photon. Okay. And energy of photon is how much energy of photon is given by the expression E is equal to your h nu, where h is your Planck's constant, and nu is your frequency of light. Okay, understood? So let's talk about the important properties of photon. Somehow in many exams it is being asked about the properties of photons. You should have know what are the properties of photon. Okay, so the first one is its mass. The mass, it's massless, so its mass is 0, and it is also chargeless. Its charge is also 0. Okay, and it doesn't depend on electric and magnetic field. Okay, understood? And one more property is it is called as a virtual particle. Okay, virtual particle virtual particle and its energy is generally given by your PC. How does it come? You know that from your de Broglie wavelength, lambda is h upon p. So your you know that uh, you know your you know c, that is velocity of light, is lambda into nu, where you can write lambda as your c upon nu, isn't it? So you can write from both the equation, that is c upon nu is equal to your h upon p. And one more thing, you know, that is E is equal to h nu, that is energy of photon. So what can you write from here? You can write from here is putting the value of nu here. E is equal to your h into nu. In place of nu, you can write p into c upon your h. So cancelling, you get pc. Okay, this is all about how E is equal to pc comes. Okay, if I will write the definition of photoelectric effect, what it will be? Definition of your photoelectric effect. So phenomenon of phenomenon of phenomenon of emission of electrons by the metals by the metals by the metals when they are exposed to light of suitable wavelengths, or you can write suitable frequency. Suitable frequency is called your photoelectric effect. Okay, this is the definition of your photoelectric effect. Okay, so it's generally a experiment done by your Hodge. It is known as your very famous experiment, that is your Hodge experiment, and it provides a direct sorry, direct confirmation of energy quantization of light, of energy quantization of light. It is very very important, that is it confirms your energy quantization of light. That is, light is made up of small quanta which is called your photons. Okay, let us talk about its properties, its characteristics or properties, its characteristics of what? Your photoelectric effect. Let us dive into it. That is, some important points I will discuss from here. Ejection of electrons takes place only when your frequency of incident light is greater than or is equal to your frequency of threshold. That is threshold frequency, that is frequency of your metal incident. New incident will be greater than equal to new threshold, then only your photoelectric emission of light becomes. Okay, and another important point is maximum kinetic energy of ejected electrons, that is k max, is given by is your h nu, that is energy of light minus your work function. What is work function? We will see from here. Work function is nothing but the minimum energy, minimum energy required to eject electrons from the metal surface. Okay, from the metal surface. Okay, this is your work function, and it is generally expressed by your phi is equal to your h nu naught, where nu naught is your threshold frequency. This is your threshold frequency. Okay, so work function is also known as your ionization energy. Ionization energy. Okay, so next we have, that is, what is its value for metals? So generally for metals, work function value varies between your 2 to 6 electron volt. Okay, and one more important point you should note down is kinetic energy max, that is your k max, is directly proportional to your frequency. This is a very very important point, you should have remember it. Okay, and the second one is your photocurrent. If I will have to derive the expression for photocurrent, how can I write it? Is your ip, that is photocurrent, is equal to your dq upon dt, which is equal to d upon dt of your q is, q is the charge, that is your number of electrons into charge of electron, that is your e dn upon dt, isn't it? Yes. And this photocurrent directly proportional to your intensity of light. Okay, remember these are very very important point. I have given it in a box so that you should remember it. Intensity of light. Okay, so kinetic energy depends upon your frequency and it varies directly as your frequency, whereas photocurrent varies with intensity of light and it is independent of your frequency. Okay, sorry. And one more important thing is, this is an instantaneous process. The whole phenomena of your photoelectric effect is an instantaneous process where no time difference between the incident radiation and your electron ejection. Instantaneous process. By instantaneous process, what does it mean? It means there is no time difference. Difference between the incident light and in electron ejection. Okay, get it? Yes. So one more important term we should discuss about is your stopping potential. Okay, in many exams the problems comes that calculate the value of stopping potential for this metal. Okay, so what does it? Stopping potential we generally denote energy as your E into Vs, where Vs is your stopping potential and its value is your h nu minus phi. That is your work function. So I can write Vs as your h nu upon E minus phi upon E, isn't it? I can further write it as Sc upon E lambda minus phi upon E, isn't it? In place of mu, I have written that is C upon lambda, as I know C is equal to your wavelength into frequency. Okay, this is the expression for your stopping potential. And next we have intensity. How can I write the intensity expression? Intensity is equal to your power of an area. So power, I can write it as energy upon time, isn't it? Energy upon time into your area. So it will become energy is nh nu is in denominator we have area into time, isn't it? Yes. So there are certain important diagrams you should know. Let me draw that for you. Important diagrams. Let me draw that for you. So the first one is between your kinetic energy max and your frequency. So what will be the character of this graph? This graph will be like this. This graph will be like this with a slope is equal to your h, that is Planck's constant, and here is your frequency nu, and here is your in y axis your k max. And if I will extend this one in negative, I will get the work function that is minus phi. Okay, here. And this one is your nu naught. That is your threshold frequency, where the graph touches or caught the x-axis. Okay, this one is our first uh, graph, or you can say diagram, that is your kinetic energy max versus your frequency. Okay, let's see the second one. The second one is about the kinetic energy max between and intensity. Okay, so what will be the nature of this graph? Let me draw that for you. Oh, it's a curved line, sorry. Okay, that is in y-axis I have to take the kinetic energy max, and in x-axis I will take intensity. Okay, and this graph will be a straight line having a okay, this one will become your h nu minus nu naught. Okay, and the third one is between your stopping potential and frequency. Third one is between your stopping potential, that is Vs, and your frequency nu. Okay, and this one will become like this, and here we can draw the slope, that is m is equal to is h upon e. Okay, so these are the three diagrams which are important, I think, for your exam. So what are the application of your photoelectric effect? The application point of view, there are photoelectric, photovoltaic or photoelectric, you can say. There is also photoelectric, I will talk about it. Photoelectric cell used in camera. In camera, we use the photoelectric effect. That is also the phenomenon of your photoelectric effect. And photovoltaic cell and burglar alarm. There also used the photoelectric effect and a lower, etc. Okay. Let me write down some important points regarding the photoelectric effect. Important points. Okay. You should remember these points. So frequency below which no electrons, some definitions I will write. No electrons are emitted from metal surface is known as your threshold frequency, as I have talked about earlier. Threshold frequency. Okay. And the second one is energy energy absorbed by electron is used in escaping from metal surface and increasing kinetic energy. So the energy absorbed by electron, in which way it is used? It is used in escaping from your metal surface and increasing the kinetic energy of electron. Okay. That's why I have written earlier that is K max is directly proportional to your frequency. Okay. And the next point, that is E. I can write E in various ways like this. E is equal to your h nu. I can also write it as h c upon lambda. In problem, you should know how to convert that is frequency to wavelength and wavelength to wave number. That's important, because in question sometimes given the data of wavelength and it asked you to find out the frequency. Okay, you should know how to convert this hc into nu bar, where nu having units of Hertz and lambda having units of your Armstrong or nanometer, and where your wave number having unit of centimeter inverse or meter inverse, and your energy having units of joule. Okay. So the fourth important point we should discuss is your, in photoelectric effect, photon is completely absorbed. Okay. In photoelectric effect, the photon is completely absorbed. Okay. And the fifth one is energy and momentum of photons are independent. Energy and momentum of photons are independent. Okay. These are all about your photoelectric effect and the important points. I have discussed all the important points regarding your photoelectric effect. The questions will come from this only. Okay. You should revise and you should remember all the important points I have discussed in this video. Okay. So thank you very much for your kindly response and watching my video. Do like, share and subscribe to my channel. It will give me motivation to make more videos and to make more work on my content. Okay. So thank you very much for watching. God bless you all. Thank you.